Hello and greetings. Hope you are safe and healthy. My name is Madhura Merikar. I am from Bharati Vidyapit's College of Engineering for Women. I am in third year of ENTC. My teammates have presented the theory, numericals and some MCQs from the topics of Unit 2 of Data Science Honours course. So let me introduce my teammates to you and their topics. The first topic is the measures of relationships, which covers covariance, Karl Pearson's coefficient of correlation. It would be explained by Mcq Questions and she is from third year computer. The second topic is the measures of position, which covers percentile, z-score and quartiles. It would be taught by Prasi Kaladeep and she is from TIT. The third topic is Bayesian Theorems, which covers Bayes Theorem, Bias Classifier, Bayesian Networks, and it would be covered by Sudisha Zare and she is from third year IT. The fourth topic would be discriminative learning with maximum likelihood. It would be covered by Pranjal Patel and she is from third year IT. The fifth topic would be probabilistic models with hidden variables. It would be covered by Shreya Jamsandekar and she is from TCOM. The last topic, linear models, regression analysis and least squares, would be covered by Komal Singh and she is from TENTC. I hope you understand what they have taught and you enjoy the learning. Over to you, Mansi. Thank you.
Hello everyone, my name is Manasi Khopre. I am studying in third year of computer engineering in Bharati Vidyapit's College of Engineering for Women. The topics that I'll be explaining you today are measures of relationship, that is covariance and Karl Pearson's coefficient of correlation. So I'll begin. So first we'll understand what measures of relationship are. So basically measures of relationship are statistical measures which show a relationship between two or more variables or two or more sets of data. So what is that? They tell you if there is any connection between the sets of data or two variables. So that is what measures of relationships are. For example, I'll give you an example. Generally, there is a high relationship or correlation between person's education and academic achievement. But on the other hand, there is no correlation between a person's height and academic achievement. So from this, as you can get that the relationship depends. So these two factors, there's a X factor that is person's education and there is Y factor academic achievement. So both these variables, they show a relationship, a high relationship. But on the other hand, when we consider other two variables, that is a person's height and academic achievement, show no correlation. The two measures of a relationship that we are going to study are covariance and correlation. Covariance and correlations are two significantly used terms in the fields of statistics and probability theory. Moving on to the first topic, that is covariance. So what a covariance is in mathematics and statistics, covariance is a measure of the relationship between two random variables. The metric evaluates how much, to what extent the variables change together. In other words, it is essentially a measure of the variance between two variables. So these are like simple statements which we can understand directly from them, that the covariance tells us what kind of relationship they have and to what extent they have. So, unlike the correlation coefficient, covariance is measured in units. The units are commuted by multiplying the units of the two variables that we consider. And there are two kinds of covariance. Positive covariance indicates that the two variables tend to move in the same direction. On the other hand, negative covariance reveals that the two variables tend to move in inverse direction. This is the formula that we use to calculate covariance for two variables, considering the variables are x and y. Xi is the values of the x variable. X bar is the mean average of the x variable. Same with the y, and n is total number of data points. Here I've mentioned few covariance applications. Those are covariance have significant applications in finance. So I'll read it to you. In the capital asset pricing model, which is used to calculate the expected return of an asset, the covariance between a security and the market is used in the formula for one of the model's key variables. So here what the two variables are is security and market, which helps us to understand what the expected returns will be. And we find relationship between the security and the market here. So pretty much sums up what covariance is. Moving on to the next topic, that is Karl Pearson's coefficient of correlation. So Pearson correlation coefficient, also referred 2 as the Pearson product moment correlation coefficient, or the bivariate correlation is a measure of linear correlation between two sets of data. The coefficient of correlation is expressed by R. Pearson's correlation coefficient is a linear correlation coefficient that returns a value of between -1 and +1. So if the value is -1, means that there is a strong negative correlation. Here, minus sign tells us that there is a negative correlation, while the magnitude tells us if it's a strong or weak relation. If the value is +1, means that there is a strong positive correlation. Same thing for this as well. The plus sign tells us that it's a positive correlation, while the magnitude tells us that it's a strong, one being the strong and 0 point anything to between 0 and 1 being the weak. Yeah, weak or positive depending on the magnitude. 0 means that there is no correlation, that there is no relation between the two variables whatsoever. Here I'll explain these two terms that I explain, these two things, that -1 +1. When a correlation, these are the examples. When a correlation coefficient is 1, that means for every increase in one variable, there is a positive increase in the other fixed proportion. For example, shoe size changes according to the length of the feet and are perfect correlations. When a correlation coefficient is -1, that means for every positive increase in one variable, there is a negative decrease in the other fixed proportion. For example, the decrease in the quantity of gas in a gas tank shows a perfect inverse correlation with speed. When a correlation coefficient is 0, for every increase, that means there is no positive or a negative increase and the two variables are not related. So this pretty much sums up what Karl Pearson's coefficient of correlation is. So these are the links that I've found while researching on this topic. So if you want to, if any of you all want to dive deeper into the topics and are curious about it more, so you can use these links to study further about the topics that I've mentioned. So moving on to the MCQs. The first MCQ is the covariance is option A, a measure of the strength of relationship between two variables, which is pretty much the definition of covariance. Option B is dependent on the units of measurement of the variables, which is correct because we read that in the PPT. An unstandardized version of the correlation coefficient, which is also correct. So this makes the correct option is D, all of these. Moving on to the next MCQ, product moment correlation is also known as option A, rank correlation, option B, Karl Pearson's coefficient of correlation, option C, concurrent deviation, option D, none of these. The correct option is Karl Pearson's coefficient of correlation, which is also known as bivariate correlation coefficient. So yeah, they have pretty much 2-3 names for it, so you can look into them. Moving on to the next MCQ, Karl Pearson's coefficient correlation coefficient is denoted by the symbol small r, capital K, capital R, none of these. The correct answer is A, that is small r. Fourth MCQ, Karl Pearson's correlation coefficient lies between -3 and +3, -1 and 0, -1 and +1, 0 and +1. We read this while explaining the Karl Pearson's correlation coefficient. I explained that the value lies between -1 and +1. So the correct answer is C. Fifth is a dashed covariance means that the asset returns move together, while a dashed covariance means that they move inversely. We studied this. These are the two types of covariance, that is a positive and a negative covariance. So a positive covariance means that the asset returns move together, while a negative covariance means they move inversely. So the correct option here is B, that is positive and negative. Sixth MCQ, covariance indicates the dash of the linear relationship between variables. So covariance, the options are direction, ratio, strength, none of these. The correct answer is direction. Covariance indicates only the direction of the linear relationship between variables. That is, it only tells you whether the relationship is positive or negative. It doesn't tell you the degree or the strength of the relation. Moving on to the next MCQ, correlation measures dash of the linear relationship between two variables. Options are direction, strength, both A and B, none of these. So as for covariance, we saw that covariance measures only the direction of the linear relationship, whereas correlation measures both the direction and the strength of the relationship. So the correct answer is C. When interpreting a correlation coefficient, it is important to look at the minus and the plus sign of the correlation coefficient, the magnitude of the correlation coefficient, the significance of the correlation coefficient. All of these statements are correct with respect to the correlation coefficient. So the correct answer is all of these. D. Now moving on to the numericals. The first numerical is based on the covariance. So I'll read the question. Assume an analyst in a company has a 5-quarter data set that shows quarterly gross domestic product, that is GDP growth in percentage X, and a company's new product line growth in percentage Y. The data set may look like, this is the data set that is given to us. So we are going to use this formula that we studied. This is the formula for covariance. So first, xi, that is the particular value, and x bar is the mean average value. So first what we are going to do is we are going to find the average x value equals 3. The average of x is 3 and the average value of y is 14.2. So we got our x bar and y bar. Now we are going to directly apply them to our formula here. So the formula here is xi, that is this number x1, minus x bar, that is the 3, the average value 3, into same for y1, that is 10, minus the average value 14.2. and as it is a summation, so we have to do summation for all the other values as well, and then divided by the number of data points. So according to that, we get the value is 2.85. After putting all the values into the formula and doing all the calculations, we get the value as 2.85. Having calculated a positive covariance here, the analyst can say that the growth of the company's new product line has a positive relationship with quarterly GDP growth. So moving on to the next numerical. This is the numerical about Karl Pearson's coefficient of correlation. So these are the two variables, height of classmates and height of benchmates, x and y. So the first thing that we do is we find out x bar and y bar. So the x bar here is 5.5 and the y bar here is 5.0. Here we find x minus x bar for all the values, and it is 0, minus 0 0.3, minus 0 0.1, 0, 0.1, 0.3 respectively. Then we find x minus x bar square. We square these values, that is 0 0.09 respectively. And we do the same for y variable as well. And then we put all these values into our formula for Karl Pearson's coefficient of correlation R, and we get the value as minus 0.613. So the minus sign indicates that the relationship is negative, that the correlation is negative, and the magnitude tells us if it's a weak or a strong relationship. So it's a strong negative relationship.
Hello everyone, I am Prachi Kaldip from IT department. Today I'm going to explain you what measures of position is. Okay, so moving forward. Yeah, here you can see. So the measure of position, name itself tells you that it is something related to measuring the position. Okay, so when we have a set of data, particularly we go through the data, and if we have given a task, like we have to just find a number from that data. So what will be your approach? First you will find the average of that data or the middle value of that data. Then you will find that which element you have to find, where it lies. Either it lies before the average or before the middle part, or after the average or after the middle part, or the value itself is the middle part. Okay, so this is basically known, this technique we can say is known as measures of positioning. Okay, so as they have given here that measures of position gives us a way to see whether a certain data point lies or falls in a sample or distribution. Okay, so it tells you that the value is average, about the average, below the average, high the average. Okay, when you have quantitative data, it's very useful for you to do this. Now, ordinal variables we have seen previously, variables those who have first, second, third, fourth, fifth, like labels, these variables. So this measures of position is very useful there on ordinal variables. Okay, so now Z scores, that is your standard score. When it comes to the standard score, it is also known as Z score. So what it tells is that how many standard deviations an element is from a mean. Okay, so particular formula is there for that. You have to not invest your time in finding. You have to just look at this formula where Z is equals to, which means standard score is equals to X will be your value of element. This will be your mean, so value of element minus mean of the population, and then divided by your standard deviation. Okay, now here again there comes a concept where you will have to interpret the Z score. Okay, how you interpret the Z score? Now if your Z score is less than 0, then the element also which you are finding is less than the mean. If your Z score is greater than 0, then your element is greater than the mean. Okay, now if your Z score is equal to 0, then your element is equal to the mean. If your Z score is equals to 1, then your element is one standard deviation greater than the mean. Okay, now if your Z score is equals to 2, so 2 standard deviations greater than the mean will be your value. Now the last point is that if your Z score is equal to -1, then it represents an element that is one standard deviation less than your value. Mean means your value is one standard deviation less than the mean. Now if your Z score will be -2, then 2 standard deviation less than the mean will be your value present at that position. Okay, here we are again finding position. Okay, now in measure of position, there are basically 3 techniques. That is, first is quartiles, second is deciles, third is percentiles. Here you can see quartile is something which is divided into 4 parts, your data. Okay, here you can calculate like 1, 2, 3 and 4. So Q1 is the first quartile, Q2 is the second quartile, Q3 is the third quartile. Okay, so 25% of your data is considered to be Q1. Okay, so your median, which is 50th person, that will be considered as your Q2, and 75th percent, which is above the median, that will be considered as Q3. Okay, so your data is your shortcut, you can say, which is divided into 4 parts. Okay, now here in deciles, it considers 10%. Like if you have 100, your number here, maybe it's 100. Okay, then 10% of your data, then 20%, 30, 40, 50, 50% will be your decile. Okay, D1, D2, D3, D4, D5, so it goes on in the numbers. Okay, so here is the formula given very specifically, that decile of your value X is equals to number, this symbol is dedicating number of values X. Okay, whatever your number is, value is, divided by total, what will be your total, into 10. Okay, now in the percentile, it comes to 1%. Again, it's coming to 1%. Again, the formula is very specific for that, and the same formula is there. Sirf here, while multiplying, you will have to multiply it by 100. This is the percentile formula. Percentiles is a very common thing for all of us. We have gone through it a lot of times. Okay, so now here is a specific example which is showing you how Z score is calculated using the formula. Okay, here you can focus. This is a very big formula. I have just enlarged it so that you can focus on this formula. Okay, this formula. So here what they have given, a student has scored 65 on a maths test, and the mean was 50 and the standard deviation is 10. You will have to calculate the z-score, as simple as that. Value minus mean. 65 is your value, 50 is your mean, divided by standard deviation. So here comes your answer. 1.5 is your z-score. Now remember, okay, 1.5 is your z-score. Apply the same formula for the second one for the history test. 30 will be your value, 25 is your mean, 5 is your standard deviation, 1 is the z-score. Okay, so now the student did better in maths because the z-score was higher. Okay, now they are asking you to compare both the tests. So this pretty surely shows that the student was good in maths, that's why his z-score is above. Okay, which you can say that it's greater, larger. Example 2, here they have given very simple values. They have just given you all the values, you have to put in the formula. Like now we are concentrating on the MCQs approach, right, for examinations. So there they will be asking you such kind of multiple choice questions, so you will have to be very particular about the formulas. Okay, as it is a mathematical thing, you will have to focus on these formulas. Now here they have given the values, so your x will be your value, this is your mean symbol, this is your standard deviation. So we have calculated them as precisely as we could, and here you can see that test A is higher, therefore it's better. As the value you keep on calculating, when you get the value you can come to a conclusion. This is what the basic technique we deal with data. So here also we are using the same approach, just we have a particular formula for that. Moving forward, now coming to the percentile, as I had told you what percentile is. Okay, so now in percentile there are specifically 2 steps we all have to follow. Okay, so firstly you will have to arrange the data in an ascending order. Why? Because your data should be accurate, you should get an accurate middle value. Okay, that's why. Then using the following formula to find the percentile. Okay, you can use your formula to find the percentile. As I had told you, the formula is that what is your value divided by total number of values you have into 100. Okay, so this here now. Okay, this is also numerical which is related to percentile. Again, we are focusing on MCQs, that's why we have to be very particular about all these things. Okay, so concentrating on these things. Okay, now firstly, what is the first step? You will have to arrange your data. Your data is not arranged. Okay, when you arrange the data, you will get this data. Now from this data, you will have to find the 50th percentile. See, using the formula is the second thing, but we are very perfect in observation. We should be perfect in observation skills, and this is not a large amount of data we have. So we can come to a conclusion that if 1 2 3 4 5 6 7 8 9 10 number of data you have, so the 5th element will be your 50th percentile. If you go percentile wise, now this is your 10th percentile, 20th percentile. Okay, in that way if you go, this is your 50th percentile, right? So 5.52, the data set has 10 values. 50th percentile will be the 5th data value. As I told you, observation skills. Okay, using the formula is the second thing, but as the data is less here, so you can figure it out. When you have a large amount of data, that time it's difficult for us to figure it out, so we can make use of those formulas. Okay, so now moving forward, yeah, now Q3 is the quartile. As I told you, quartile 1, quartile 2, quartile 3. So they are asking what is quartile 3. Quartile 1 will be 25%, quartile 2 is your median which is 50%, quartile 3 is your 75%. This is the thing I told you in that slide. Okay, remember these things, and moving forward you will have to apply those. So now here this will be your Q1, this is your Q2, this will be your Q3. The value is 75 present here, 75%. So your Q3 is 75. Okay, this value is also the 75th percentile. Multiple choice question. Okay, so here find the median of the following data. They have given us data, you have to find the median. Again, observation skills. 7. 7 is the count of the data you have. Fourth element will be the middle element, so that 3 elements at the left remaining, 3 elements at the right remaining. The value is the middle value, median. 280 will be your median. Now first quartile, let me tell you. First quartile is known as lower quartile. Second quartile is known as median. Third quartile is known as upper quartile. Okay, now this MCQ, middle value of an ordered array of numbers is known as median. When you have ordered array, you find a middle value. That's the median. Now, according to percentiles, the median to be measured must lie in 50th. Okay, because I have told you a lot of times that the median is the middle value, middle value, middle value. Okay, so middle value is the 50th one. We must arrange the data before calculating in median. This is also discussed a lot of times. Deciles means 1:100. Deciles shows that. As I told you, third quartile is also known as upper quartile. They are asking you the third quartile. Firstly, you will have to arrange the data. After you arrange this data, you will get your quartile present somewhere between 38 and 42. So what will be the middle of 38 and 42? 40. That's why the third quartile will be 40. Okay. Now what is the median of the data? Again, you will have to arrange this data. 1, 2, 3, 5, 5. 3 will be your median. So that left side 2 elements, right side 2 elements, your middle value is 3. Now they are asking you something which is theoretical, that the quartiles, median, percentiles and deciles are all central tendency classified as positioned average. Why? Because they particularly show us where your data lies. It is related to positions. That's why position averages. Okay. Now a raw score can be converted to, now you have given a raw score. So you can convert that into all the possible things when you have given a specific test. Okay. Like standard score, you have the formula, percentile, observation skills and formula, both things. And this is something new for you. This is also something which is used to calculate the value of data, we can say. So all these are possible when you have a raw data score depending on your specific tests. Okay. So these are the references I have used to prepare my video to make you understand my topic. So that's it. The next topic will be explained by Sudhisha. Thank you.
Probability is at the very core of a lot of data science algorithms. In fact, the solutions to so many data science problems are probabilistic in nature. The Bias Theorem, a major aspect of the Bayesian statistics, was created by Thomas Bayes, a monk who lived during the 18th century, which enables us to work on complex data science problems and is still taught at leading universities worldwide. Hello everyone, I am Sudhisha Zahari from 3rd year IT at Bharati Vidyapeeth's College of Engineering for Women, Pune. And in today's session, we will explore the Bias Theorem in detail along with some of its applications and pros and cons, and then we'll be going on to the Bias Classifier and also on the Bias Network. So since there's a lot to unpack in this session, let's get going. To understand what the Bias Theorem actually means, we need to look at some prerequisites, and those are the basics to understand the Bias Theorem. So let's start. First, experiment. Now, when we talk about an experiment in mathematical terms, an experiment is a planned operation carried out under controlled conditions. Example, tossing a coin or rolling a die or drawing a card out of a pack of 52 cards are all examples of experiment. The result of that experiment is called the outcome, and the set of all possible outcomes of an event is called as the sample space. For example, if the event is of tossing a coin, and the sample space for that will be tails or heads, since there are 2 possible outcomes only. An event is a set of outcomes that is a subset of the sample space of an event. example, the experiment of rolling a dice and define events E and F as E will be an even number which is obtained, that can be either 2, 4 or 6. F can be a number greater than 3 is obtained, 4, 5 or 6. A random variable is exactly what it sounds like. It is a variable which can take on random values, with each value having some probability, which can be 0 also. Next, independent events. If the occurrence of one event does not have any effect on the occurrence of another, then those two events are called independent events. Exhaustive events is a set of events that is said to be exhaustive if at least one of the events must occur at any time. Conditional probability, and this is the foundation for Bayes' theorem. The conditional probability is defined as the probability of an event A given that another event B has already occurred, that is A conditional B. Now, let's move on to the Bayes' theorem, shall we? Now, what is the Bayes' theorem? Let me ask you one interesting question. Have you ever seen the popular TV show Sherlock or any other crime thriller show? Think about it. Our beliefs about the culprit change throughout the episode. We process new evidence and refine our hypotheses at each step. This is the Bayes' theorem in real life. Essentially, Bayes' theorem describes the probability of occurrence of an event related to any condition. It is also considered for the case of unconditional probability. Bayes' theorem is also known as the formula for the probability of causes. Now, where do we apply Bayes' theorem in data science or ML or AI? The Bayes rule is used on various occasions, including a medical testing for a rare disease. With Bayes rule, we can estimate the probability of actually having the condition given the test is coming out positive. The Bayes theorem also allows updating the probability prediction of an event by observing new information of the real world. It is also an important tool in machine learning and artificial intelligence because it provides a way of thinking about the relationship between the data and a model. A machine learning algorithm or a model is a specific way of thinking about the structured relationships between the data. Now, mathematically, how is the Bayes theorem represented? Let's look at that. Mathematically, imagine we have two overlapped events, A and B. It can be, for example, event A is I get wet today, and event B is it will be rainy today. In one way or the another, many events are related to one another. As in our example, let's calculate the probability of A given that B has already happened. Since B has already happened, that is, it has rained today, the part which now matters for A is the shaded part, which is interestingly A intersection B. It denotes the AND operation. So the probability of A given B turns out to be probability of A given B is equal to probability of B given A into probability of A upon probability of B. Now here, probability of A and probability of B are the probabilities of observing A and B independently of each other. That's why we can say that they are marginal probabilities. Now, marginal probability is the probability of event A occurring independent of any other event B. That is, it marginalizes the event B. That's why we can say that these are marginal probabilities. The probability of B given A and A given B are conditional probabilities. Here, PA is called the prior probability and PB is called the evidence. B given A is called the likelihood and probability of A given B is called the posterior probability. Equivalently, Bayes' theorem can also be written as posterior is equal to likelihood into prior divided by evidence. Now let's go on to the next topic, which is the bias classifier. Naive Bayes is a supervised learning algorithm which is used for classification tasks, as we seen earlier. Hence, it is also called as naive Bayes classifier. As other supervised learning algorithms, naive Bayes uses features to make prediction on target variable. The key difference is that the naive Bayes assumes that features are independent of each other and there is no correlation between the features. However, this is not the case in real life. This naive assumption of features being uncorrelated is the reason why the algorithm is called naive. Now, the naive Bayes classifier calculates the probability of a class given a set of features values. Input these into the Bayes theorem, we get the following equation. Here, P of yi given x1, x2, xn means the probability of a specific combination of features given a class label. The probability of x1, x2 up to xn can be removed to simplify the equation because it only normalizes the value of a conditional probability of a class given an observation probability of yi given x1, x2, xn, all the features. The probability of a class P of yi is very simple to calculate with the following equation. Now, the type of distributions depend on the characteristics of the features. For binary features, that is yes or no, true or false, or 0 or 1, that is a Bernoulli distribution. For discrete features or word counts, it is a multinomial distribution. And for continuous features, that is Gaussian or normal distribution. It is common to name the naive Bayes with the distribution of features, that is Gaussian naive Bayes classifier, and for mixed data sets, a different type of distribution may be required for different features. Now, we have seen the Bayes theorem and what is a Bayes classifier and how we calculate the probability. So let's look at pros and cons of the naive Bayes algorithm. The pros. The assumption that all the features are independent makes the naive Bayes algorithm very fast compared to the complicated algorithms. In some cases, the speed is preferred over accuracy, and it also works well with high-dimensional data such as text classification, email spam detection, and so on. It has one disadvantage, however, that the assumption that all features are independent is not usually the case in real life. So it makes the naive Bayes algorithm less accurate than the complicated ones. Speed comes at cost, isn't it? Now, let's go to the Bayesian network. Bayesian networks are the type of probabilistic graphical model that can be used to build models from data and or expert opinion. They can be used for a wide range of tasks, including prediction, anomaly detection, diagnostics, automated insights, reasoning, time series prediction, decision-making under uncertainty, and so on. For example, a Bayesian network could represent the probabilistic relationship between disease and symptoms. Given the symptoms, the network can be used to compute the probability of the presence of a disease. Now let's look at the figure 1, which is the Bayesian belief network illustration. Let's understand what the Bayesian network actually represents. Now, the Bayesian network is a computational model which is based on graph probability theory. The structure of BBN is represented by a directed acyclic graph or DAG. Formally, a DAG is a pair n, a, where n is the node set and a is the arc set. If there are two nodes u and v belonging to n, there is an arc going from u to v, then u is termed as the parent and then u is termed as the parent and v is termed as the child of u. In terms of cause and effect relationship, u is the cause and V is the effect. A node can be a parent of another while also being a child to a different node. An example is illustrated in this figure. A and B, we can see, are the parents of U, and U is the child of A and B, whereas for V node, U is the parent. With respect to cause and effect relationship, A and B are direct causes of U. U is directly causing V, implying that A and B are indirectly responsible for the occurrence of V. Now, the Bayesian networks satisfy the local Markov property, which states that a node is conditionally independent of its non-descendants given its parents. Let's look at the next example to clearly understand what a Bayesian network is used for. In the example that we see here, we can see that rain has an edge going into wet grass. It means that the probability of wet grass, given that rain has already occurred, will be a factor whose probability values are specified next to the wet grass node in a conditional probability table. Two events can cause the grass to be wet: an active sprinkler or a rain. Rain has direct effect on the use of sprinkler, namely when it rains, the sprinkler is usually not effective. This situation can be modeled with a Bayesian network, which is shown here on the right. Each variable has two possible values, T for true and F naming for false. Thus, this model, which we have implemented here, can answer all the questions about the presence of a cause given the presence of an effect, so-called inverse probability. Like, what is the probability that it is raining given that the grass is wet, by using the conditional probability formula and summing all over nuisance variables. Now, that is the Bayesian network. This has two major components which is involved. The first is the structured learning, which involves the discovering that the directed acyclic graph best describes the causal relationships in data. And number two is the parameter learning, which involves learning about conditional probability distributions. Let's move on. Now we will be seeing some numericals, which will be based on the three topics that we have covered so far, so that we can be able to solve all the problems that are actually solved using those in data science. Now, question 1 is given as: Nana receives emails that consist of 18% spam. Of those emails, the spam filter that Nana has is 93% reliable. This means that 93% of the mails which are marked as spam are actually spam. If the mail is marked as spam by her spam filter, we have to determine the probability that it is really a spam email. Now, detection of an email to be spam or non-spam is the most basic application of Bias Theorem. It classifies the emails on basis of the words which are used in spam emails versus the non-spam emails. For example, mostly we can observe that 60% to 70% of the emails which are spam contain the words buy, sell, offer, limited, period, etc. So using these, the model is trained to detect whether a given spam mail is spam or not. Excuse me. Now we'll solve this given problem. Now, since it is already given that the 18% of those emails are spam, we can imply that the 82% are non-spam. Since 18% are spam and 82% are not spam, we can use the Bias theorem to calculate the probability that a mail marked as spam is really a spam, which can be calculated as probability of being spam and being detected as spam divided by the probability of being detected as spam, which equals to 0.18 or 18%, which are spam emails, and into 0.82, which is 82%, which marks the emails are not spam. Inputting these values, we get the value to be 0.5, which can be converted into 50%. So this implies that 50% is the probability that the spam filter will determine the probability that it is really a spam email. Moving on. Question number 2. Two boxes contains candies placed on table. The boxes are labeled B1 and B2. The box B1 contains 7 cinnamon candies and 4 ginger candies, and the B2 box contains 3 cinnamon candies and 10 pepper candies. The boxes are arranged so that the probability of selecting box B1 is 1/3 and the probability of selecting box B2 is 2/3. Suresh is blindfolded and asked to select a candy. He will win a color TV if he selects a cinnamon candy. If he wins a color TV, what is the probability that the marble or candy was from the first box? Now, here we are given two boxes B1 and B2. There are 4 candies placed in 2 in each box. Now, A should be the event of drawing a cinnamon candy, because we have to calculate if he wins a color TV, and when he does win a color TV, if he selects a cinnamon candy, which is placed in box B1 and B2. So B1 should be the event of selecting the box B1, and B2 will be the event of selecting box B2. Then probability of B1 is already given 1/3 in the question it is stated, and the probability of B2 is 2/3 also stated. Given that Suresh has won the color TV, the probability that the cinnamon candy was selected from B1 will be calculated as probability B given A will be equal to probability of A given B1 into probability of B1 upon probability of A given B1 into probability of B1 plus probability of A given B1 into probability of B2. We calculate the probabilities of selecting box B1 and box B2 simultaneously. After we input all the values which we have here, we can get, after the solving the equation, we get the value 7/13. So the correct answer is 7/13. Now imagine if we have a party on a Sunday and an exam on Monday. Too much food on Sunday could lead to a lack of concentration on Monday, which would reduce the probability that you pass the exam. Another consequence of reduced concentration could also be stressed with your roommate as you forgot to clear the room after dinner. This lack of concentration can also be due to allergy that you have after you eat some type of food items. Now, we have to consider the random variables that are given as follows, which can either be true or false. A, given that too much food on Sunday. B specifies if allergy strikes. C is the reduced concentration on Monday. D is you pass the exam. And E, if you have some stress with your roommate. This correspondence Bayesian network is shown in the figure here. Now suppose A and B are conditionally dependent if C or any of its descendants, that is D or E, have received evidence. Now we have to state if D's statement is true or false. Now definitely this statement will be true because these two, that is having too much food on Sunday or allergy being striking, are dependent conditionally on C, that is reducing concentration on Monday. So that is definitely a true statement. Next, E is conditionally dependent on A, B, D if C is not instantiated. Now this is false because we say that there is an edge going from A to C, B to C, and so on, connecting up to E. So this means that E is conditionally dependent on A, B, D and C. if C has instantiated. Next, D is conditionally independent of A, B, and E if C is instantiated. Now this statement, however, is true because since C has been instantiated, that is, we have too much food on the Sunday, we can be stricken with an allergy, and we can have reduced concentration on Monday, which can lead to passing the examination when C is already instantiated. Next, D and E are conditionally dependent if C is not instantiated. This also is a true statement. Next, in an objective type examination, each question has 4 options of which only one is correct. A student is taking the examination either guesses or copies or knows the answer to a question. The probability that he guesses is 1/3 and the probability that he copies is 1/6. The probability that he answers correctly if he copies is 1/8. If an answer is given to be correct, find out the probability that the student knew the answer. Now we see that the student can make 3 moves with the associated probabilities, which can be as follows. Probability of making a guess is equal to 1/3, which is already given in the question above. Probability of copying is 1/6, also given, and probability of knowing the answer will be 1 minus 1/3 plus 1/6, probability inverse theorem, and which can be calculated as 1/2. Now, here we have the Bayesian belief network constructed for the following question. The student is an entity which can have 3 probability associated moves. He either guesses the answer, or he copies, or he actually knows the answer. Now, an answer being guessed, copied, or knows can have 2 more probabilities associated with it. It can be either correct or incorrect. If he copies, however, we know that the probability of his answer being correct is 1/8. Also, it is given here. And also, if he guesses, we know that with any 4 other options which is equal likelihood, it means that the probability of his answer being correct is 1/4. Now we see that we have 3 paths leading to the correct answer. When we want to find that the probability of the bottommost path, that is the probability that the student knew the answer and he answered it correctly. Now this probability can be calculated simply by using the Bias theorem, as probability knew given answered correctly will be equal to 1/2, that is the probability of knowing the answer, into 1 correcting the correct answer, divided by 1/3 guessing into 1/4 correct answer of the guess, plus 1/6 into 1/8 plus 1/2 into 1. We just considered all the paths, the 3 paths which lead to correct answers for all the 3 cases. And now after computing this equation here, we get the value to be 24/29. So that is the probability that if the answer is correct, the probability was that student already knew the answer. Now that was all for the related numericals. Now let's go on to the theory part, that is the questions related to theory. Now, question number 1 states, the Bayesian theorem was named after its inventor. Who invented the Bayesian theorem? Reverend Thomas Bayes, Stuart Bayes Hamilton, Bayes Canny, or none of the above. Now, as we saw in the earlier slides, that I already told you that the Bayesian theorem was invented by a monk who lived in the 18th century. His name was Thomas Bayes. Well, his full name is Reverend Thomas Bayes. And since he created the Bayes theorem, it is named after him. Question 2. State whether the following condition is true or false. In Bayesian theorem, it is important to find the probability of both events occurring simultaneously. True or false? Now, it should be noted that in the Bayesian equation, that is probability of A given B is equal to probability of B given A into probability of A upon probability of B, we need not find the probability of both events occurring simultaneously. That is probability of A union intersection B. We can calculate the same using the Bayesian equation. So we can say that in the Bayesian theorem, it is not important to find the probability of both events occurring simultaneously. So this statement is false. Question 3. The previous probabilities in Bayesian theorem that changed with help of new available information are classified as posterior probabilities, because we can see in the equation where probability of A given the probability of B will be equal to the probability of B given A into probability of A upon probability of B. Here the probability of A given B is called the posterior probability, which is the previous probabilities in the Bayes theorem which were changed with the new available information. So the answer here is posterior probabilities. Question 4. How do we perform Bayesian classification when some features are missing? Now, if we get a Bayesian model where we have some features to be missing, we have to handle those data set to be able to calculate our conclusions or insights. So, what do we do? Here, we don't use the general methods of handling the missing values. That is, instead, we integrate the posterior probabilities over missing features for better predictions. That is, we integrate the posterior probabilities over the missing features. Question 5. In the naive Bayes algorithm, suppose the prior for class W1 is greater than W2. Would the decision boundary shift towards the region R1? Region for deciding W1, or towards the region R2, region for deciding W2. Now, upon shifting the decision boundary towards region 2, we preserve the prior probability proportion, since prior for W1 is greater than W2. So, it would be shifting towards the region R2. Question 6. Which of the following statement is true about the Bayes classifier? The Bias Classifier works on the Bayes theorem of probability. The Bias Classifier is an unsupervised learning algorithm. This statement, however, is false because we saw that the Bias Classifier is an supervised learning algorithm. The Bias Classifier is also known as the maximum appropriate classifier. This is also false. It assumes that the independence between the independent variables or features. Now here, we cannot say that this statement is entirely correct because the naive classifier assumes that the features are independent of each other and there is no correlation between the features. So this statement also is false, which leaves us with the Bayes classifier works on the Bayes theorem of probability. So this statement is correct. Question 7. The updated probabilities of an event in the light of newly collected data are called as prior, posterior, conditional, or simple. Posterior probabilities are the ones which are updated probabilities of an event in light of newly collected data. And the estimated probabilities of an event before any new data is collected are called as the prior probabilities. Question 9. The fire alarm rings, but there is no fire. Now this is an example of a false positive. Question 10. A person acquitted of crime, but in reality they were guilty. This is an example of false negative. Now that's it from my side. Thank you very much for listening, and thank you.
Hello everyone, myself Pranjal Patil. Currently I am studying in third year Information Technology branch at Bharati Vidyapeeth College of Engineering. So today we are going to discuss about generative and discriminative learning with maximum likelihood estimation method. So basically both the generative and discriminative learning are used for classification and both can be supervised, but the way they go for separating positives from negative are very different. So first we will see generative learning. The generative model is considered as a class of statistical models that can generate new data instances. This model is typically used to estimate probabilities, modeling data points, and distinguishing between classes based on these probabilities. So here are some key points of generative learning. Probabilistic model of each class, decision boundary where one model becomes more likely, natural use of unlabeled data. So now we will see all these key points in detail. Generative approach try to build model of positives and negative, and what I mean by the model here is it's some characterization of the entire population of the positives. So by generative model we will come up with some way to characterize a distribution that what kind of positives you likely to see and what kind of positives you do not likely to see. Then we will do same thing for the negatives, and if you ask a generative model to do classification, what it will do is look for boundary space where one model becomes more likely than another, and then we will compute the probability, and as this probability reaches to the 5 boundary or boundary limit, this at that time where we can say this is the optimal way. So generative model usually probabilistic and generative model naturally use the unlabeled data. So here are some examples of generative learning that are naive Bayes or Bayesian networks, Gaussian mixture model that is GMM, hidden Markov model HMM, linear discriminant analysis LDE. So now we will go for discriminative learning. Discriminative model refers to a class of models used in statistical classification, especially in supervised machine learning. It is also known as conditional models. It learns the boundary between classes or labels in a dataset that distinguish decision boundaries through observed data such as pass, fail, win, lose, alive, dead, or healthy and sick. Again, here are some key points about the discriminative learning. Focus on the decision boundary, more powerful with lots of examples, not designed to use unlabeled data, and only supervised tasks. Now we will see all these key points in detail. So discriminative approaches are different as discriminative algorithm put all their work or all their efforts into modeling the boundary between two classes. So the boundary is not always going to be linear, but the point here in consider is the whichever the points are near to the boundary are not important, but what it cares is the line that separates the positives from negatives, and the points that are the closest to this boundary that make to all the decision. So a discriminative approach can efficiently ignores most of your data, even the label data. They will just focus on the important ones. So discriminative approach is more powerful when you have a lot of training examples or the best classifiers, and we can't really use the discriminative approach on unsupervised tasks, but sometimes we can use generative learning for unsupervised tasks. Now we will see some examples of discriminative learning: logistic regression, support vector machine, decision tree, and random forest. Here is a summary of both the models. First point in generative model, model probability of x comma y. In discriminative model, model probability of y onto x. In generative model, the distribution of individual classes, and in discriminative model, it learns the boundary between classes. Generative model can generate synthetic data points and discriminative model usually better in performance. Examples of generative model are hidden Markov model. Again, in discriminative model, examples are logistic regression, SVM. So we are done with the generative model and discriminative model. Now we will go to the next topic, that is maximum likelihood estimation method. So the goal of maximum likelihood estimation is to find the optimal way to fit a distribution to the data. And the distribution says most of the values you measure should be near to the average. And the term likelihood here is refers to the situation where you are trying to find the optimal value for the mean or standard deviation for the distribution given or a bunch of observed measurements. So here we have one graph. We will consider this graph for our estimation method. So there are some data is given, that is 100, 200, 300, 400, 500 with different weights, and we have distributed them as 100, 200. After that, here what is our goal is to find the optimal way to fit this distribution on the given data. So we have to find optimal way to fit the distribution, that is 100, 200, that distribution on the given different weights. So what distribution says is most of the values you measure should be near to your average. So here I have circled average one, that is we will consider it as a 250 from this value, that is we consider mean average as 250. So all the values given in the data or distributed should be near to the average. So 100, 200, 300, 400 and 500 are nearly close to the mean, that is 250. So that 250 number is nothing but the likelihood. So here are some other points related to the maximum likelihood estimation. Sometimes the probability density function are not known. So these probability density functions are to be estimated from the available data. Maximum likelihood method views the parameter as quantities. Whole values are fixed but unknown. The best estimate of their value is defined to be one that maximizes the probability of obtaining the sum samples actually observed. Let us consider an n-class problem with feature vector distributed according to probability of x with wi, and here I is nothing but the 1, 2, 3 up to n. Assume that these likelihood functions are given in a parametric form and the corresponding parametric form the vectors theta I. To show the dependence on theta I, it is written as a probability of x with wi onto theta I. Next, the objective of this method is to estimate the unknown parameters using a set of feature sectors in each class. It is further assumed that from one class do not affect the parameter distribution of others, then problem can be formulated as a independent. Thus, the problem can be solved for each class independent. Let us here assume that x1, x2, x3 up to xn be the random samples drawn from the probability density function, that is probability of x onto theta. We form the joint probability density function, that is probability x onto theta, where x is nothing but our random samples drawn from the probability density function, that is, or we have considered it as earlier that x1, x2, x2, xn, that is our x sample, is the set of samples. Assuming statistical independence between different samples, we have probability of x onto theta. So here p probability of x1, x2, x3 up to xn onto the theta. So in this graph it is shown that theta is the theta of the maximum likelihood estimation and the probability density function, that is x onto the theta. Now we will see one example of maximum likelihood estimation. There are two sports teams in a school A. A sample team members' height and weight are different between the teams. So here team A is given and team B is given with their respective heights and with their respective weights. So now first we will see the likelihood model in the matrix form. So it is the likelihood function or likelihood model. So what is probability of x onto A is probability of x, that is the new student belonging to the team A, and 1 upon 2 pi. So pi value is 3.1416 and here n by 2 is refers to the number of feature sets. In this example n is equal to 2. Why it is n is equal to 2? Because we use the height and weight. Again, this capital V is refers to as a variance covariance matrix of height and weight in team A, and this capital M is considered as a mean matrix of height and weight in team A. Now we will first compute the mean matrix, that is our capital M. So M is a n by 1 matrix since we use two feature sets, that is height and weight. So n is equal to 2. So M is nothing but a 2 by 1 matrix as it is shown over here. Mean height, first row contains mean height and second row contains mean weight. But one more thing here, that is it is not necessary to write first parameter or first feature in the first row. You can write weight in the first row and height in the second row, but just make sure that whichever sequence you are taking in the mean matrix, you have to follow that sequence throughout the example. Now we will see how to compute variance covariance matrix, that is capital V. So V is a n by n matrix since we use two feature sets, that is height and weight. N is equal to 2. Why it is n is equal to 2? Because we are using the two features that are the height and weight. So V is nothing but 2 by 2 matrix. As here shown, it is shown over here, variance of height, covariance of height and weight, covariance of height and weight, and variance of weight. Now we will actually start the calculations. So first we will calculate mean matrix for team A only. So after calculating mean height, we will get the value as 132.4 and mean weight as 38.4. So we get the mean matrix over here, that is 132.4 and 38.4. Next we will calculate the variance and covariance matrix for team A. But here first we need to calculate the variance only. So variance of height is 31.3 and variance of height is 7.3. In the next step, we will calculate covariance of height and weight of team A together, that is 5.55, and here we get our covariance and variance matrix for team A, that is 31.3, 5.55, 5.55 and 7.3. Just don't be confused over here that first we have calculated only variance and then we have calculated covariance. Okay, so next, as we have got every value, so we will just put those values in our likelihood model and then we will get the probability as 1.902 into 10 raised to minus 6. So the probability of the new student belonging to the team A is quite small, that is probability of x onto the team A is equal to 1.902 into 10 raised to minus 6. So let's calculate probability of x onto team B and compare which one has a higher value. So here we have our team B with their heights and weights. we will calculate mean height and we get the value as 161.67 and mean weight as 46.67, and then we get our mean matrix for team B is 161.67 and 46.67. Now what we will calculate? We will calculate the variance of height and variance of weight for team B. After calculating, we get the value as 58.333 and 17.33. Now we will go for covariance of team B. So after calculating, we will get the value as 13.33. And here we got our complete variance and covariance matrix for team B, that is 58.33, 13.33, 13.33, 17.33. And now we will compute the probability for team B. So after putting all the values, we get the probability at 0.00376. So now in the next step, we will compare the probabilities of both the team, that is team A and team B. So here is the probability of team A is 1.902 into 10 raised to minus 6, and probability of team B is 0.00376. So the new student is most likely from team B, since probability of B is greater than the probability of X. So here are some tips while using the maximum likelihood estimation. Make sure you use meaningful feature sets. Example, student ID is not appropriate here. Normalize the feature sets using z-score if the feature sets values are way apart. Normally, we usually use log likelihood since it can avoid those small numbers being computed in the probability. Now, we will see some MCQ questions for our topic. So, first question is modeling a classification rule directly from the input data, like in logistic regression, fits which of the following classification methods? So options are given: discriminative classification, generative classification, probabilistic classification, and all of the above. So if we go, if we look at into the question, here they have mentioned input data like in logistic regression fits. So logistic regression is one of the example of discriminative classification. So the option A is the answer, that is discriminative classification. Next question, discriminative model is also referred as a conditional model. Option C. We have already seen it in our explanation of the discriminative model. Now we will go for question number 3, that is characteristics of discriminative learnings are focus on the decision boundary, not designed to use unlabeled data, only supervised tasks, and all of the above. As we have seen some key points about the discriminative learning, all the key points are nothing but the characteristics of the discriminative learning. So all A, B, C options are correct. So option D is the answer, that is all of the above. Now next question, which of the following are not true about generative models? So the option B is the answer, that perceptron is a generative model. So it is a wrong statement and all others are the correct statement. Now we will go for the question number 5. Which of the following is an example of discriminative algorithm? So I have already shown some example earlier about of discriminative algorithm. So we'll just go in the option decision tree and random forest, naive Bayes, hidden Markov model, and none of the above. So decision tree and random forest are the examples of discriminative algorithm. So option A is the answer for this question. And other two models are the examples of generative algorithm. Now next question, which of the following is not an example of generative algorithm? So not an example of, not an example of. Question is asked for no example. So first option is logistic regression, second is naive Bayes, third is hidden Markov model, and D is linear discriminant analysis. So logistic regression is example of discriminative algorithm, and other all are examples of generative algorithm. So here answer is A, that is logistic regression is not an example of generative algorithm. Next question, which method of estimation is used to maximize likelihood function? So options are given, method of minimum variance, method of movements, method of maximum likelihood estimation, and none of these. As we have already seen in our previous topic, that is maximum likelihood function, what is the purpose of that method is to maximize the likelihood function. So option C is the correct answer here, that is method of maximum likelihood estimation is used to maximize the likelihood function. Next question, which of the following is wrong statement about the maximum likelihood approach? Option A is this doesn't always involve probability calculations. It finds a tree that best accounts for the variation in the set of sequences. Option C is the method is similar to the maximum parsimony method. And option D is the analysis is performed on each column of a multiple sequence alignment. So here option A is the answer, as what it says is this method doesn't always involve probability calculations. So as we have seen in the example, it includes the probability calculation. So it is a wrong statement over here. Now we will go for next question. The main disadvantage of minimum likelihood method is that they are mathematically less folded, mathematically less complex, computationally loosey, computationally intense. So as we have seen in the example, it is not less complex, it is little bit more complex to calculate all those calculations and all those matrix. So here disadvantage of the maximum likelihood is computationally intense. So option D is the answer. Now next question is, which of the following models can be estimated by maximum likelihood estimator? So support vector machines is the first option, second option is maximum entropy model, third option is k nearest neighbor, and D last option is naive Bayes. So what they have asked is models can be estimated by maximum likelihood estimator. So the answer is maximum entropy model can be estimated by using the maximum likelihood estimator. So here are some reference links regarding to our topic. If you want, you can go through these. Okay, so that's all from my side. Thank you.
Hello everyone, my name is Shreya Jamsanekar. I am a third year computer engineering branch of BBCOEW, and today my topic from Data Science Unit 2 is Probabilistic Models with Hidden Variables. Now the title itself is big, so I've broken it down into three things: probabilistic or probability, models, and hidden variables. Now in probability, we have two things to learn: max likelihood log and naive Bayes algorithm. Now max likelihood log is pretty important. But let's make the first thing, likelihood. Likelihood is the measure of being able to predict the data set that you already have. Let me give you an example. Let's say we have the data of the weather of the last 100 days and we have a model. We give 80 days of data for the model to train on, and then we test it on the remaining 20 days. If the model is able to correctly predict each and every day of those 20 days, then it has the maximum likelihood. We need to aim for maximum likelihood because the models fit that data perfectly. And log is basically the measure of that max likelihood. So we use the logarithm to find the max likelihood of a model. Now naive Bayes algorithm, we all know, if we want to predict a given event from another given event probability, then we use naive Bayes algorithm. In models, we will be studying probabilistic model, Bayesian network, Markov network, and Gaussian mixture model. And in hidden variables, we have hidden class variables and EM algorithm. So let's jump right in. The first is probabilistic model. Probabilistic model is completely based on randomness and it plays a role in predicting future events. The opposite of that is deterministic, which has exactly each and every value. So for example, if we take a look at this graph or the model, we have A and B, which are nodes representing random variables. These edges are the association between these random variables through which we can calculate different probabilities of different variables. So that is probabilistic model. It is a huge topic. In that, there are different parts of models like the Bayesian network. Now the Bayesian network is known for two things, mainly the directed edges and the product of conditional probabilities. So the Bayesian network is a graph which with vertices representing observable variables only. So if you look at this example, you can see whether the variables that are present, we can observe them, whether it is cloudy or whether it is not, whether it is raining or whether it is not. The directed edges represent conditional distributions, and there are two things that we have to remember about the variables. If the vertices are binary or 0, 1, then the conditional distributions are Bernoulli distributions. If the vertices are continuous values, then the conditional distributions are Gaussian variables. The joint probability distribution is formulated as a product of conditional probabilities. So like I said, if we look at this example, we have the variable cloudy. The probability of the sky being cloudy and not cloudy is 0, 5 in both cases. But knowing if cloudy will affect the variable rain is found out by the product of marginal probabilities. So if you can see here, cloudy being true and it being rainy has a value of 0, 8. Cloudy being true and rainy being false has a value of 0, 2. So we have used a product to find the probability of rain. Similarly, we use sprinkler, cloudy and rain to find the probability of the grass being wet. And you can see the table here. So that is Bayesian network. Markov model is the opposite of Bayesian network. It uses undirected edges instead of directed edges, and it can allow cycles. The one thing that we have to remember here is that the undirected edges represent joint probabilities of cliches in the graph. And there is a thing called hidden Markov model. So hidden Markov model is similar to the hidden layer in the neural networks. You can see here, this is the Markov model. I'll explain more of hidden Markov model in the MCQs that we have coming up. The Gaussian mixture model, it is a mixture model comprising of unspecified combinations of multiple probability distribution functions. The one thing that we have to remember here is the data sets aren't exactly placed into the graph. We have to have the estimation of means and standard deviation parameters placed into the graph. It is used as a density graph basically. So we keep on repeating until we find a good set of latent values and the maximum likelihood is achieved. So I'll just read this out. A statistical procedure or learning algorithm is used to estimate the parameters of the probability distributions to best fit the density of a given training set. So we keep finding the estimation of mean and standard deviation parameters. We put them into clusters. The more the density of the clusters is higher, the more the height of the Gaussian mixture model graph. So that is a Gaussian mixture model. Now coming to the hidden variables. The first thing that we think of is why do we need to study hidden variables in probabilistic models, right? So the first usefulness of hidden variables is lower complexity. And the second is discovering new structures. So for example, let's say we're trying to make a model on how to detect cancer. Now we don't exactly know how cancer occurs, right? So there may be factors that we are including that may or may not be needed. So if we, let's say some of those variables are hidden, then the complexity of that model may reduce. So that is the first reason, discovering new structures. maybe if we remove some of the variables or some of the variables are not present, we may get a different model that is more accurate than the previous models. So these are the two reasons why we study these type of models. Now there are two types of data sets that we can have in a hidden variable probabilistic model. If the data set dependent has too many missing values, then we can't really do anything because we can't even use probability techniques to guess them. If some are missing, then we can use probability techniques. Now there are three strategies that can be used to find these hidden variables, and these three strategies are the generalized version of the EM algorithm that we're studying next. The first is we can ignore them. We can use likelihood and marginalize the hidden variable, and we find the sum of log L and pH. Now log L is the logarithm of the maximum likelihood, and the pH is the probability of those hidden variables. We take the sum of them and we marginalize those variables into finding the maximum likelihood. The second is estimating parameters, which is basically the standard counting procedures. The standard counting procedures are mean, median, and mode. And the last is fill with distributions. So soft values by estimating new joint probability method. This is basically rounding off those variables into their into the most common or the most required value. Now try this in iteration till log L converges. I'll explain what converges is in the next part, but we have to keep on repeating these strategies till we get the maximum likelihood. Converges is basically when we find a max value after which the logarithm starts reducing again. Now the EM algorithm. The EM algorithm has two things mainly in it, the E step and the M step. E step is estimating the expected value for each latent variable, and M is optimizing the parameters of the distribution using maximum likelihood. Optimizing the parameters basically is iteration until we find a good value. The first step is finding the theta, which is the max probability of data, but it is too complex to directly find theta, so we use G. G has the values theta and the complement of P in it, and we use trial and error method to try to find it. So it can be keeping theta as a fixed value and finding different variables or different values for the complement of P, or keeping complement of P fixed and finding different values of theta. The one thing that we have to remember about this function G is has to have the same global and local optima at convergence. Now let me explain that. Let's say we're trying to find the minimum optimum of something, okay? Now in a given data set range, we keep putting values into it until we find a local optima, because after that the value starts increasing again. Now the problem here is this is the local optima for that data range only. We want to find the global optimum, which is the minimum optima for the whole data range. Similarly, for max likelihood, we don't want to find the local maximum or the local optima. We want to find the global maximum, which is the maximum value or maximum likelihood for the whole data. So even if your values start decreasing in or converging, as I've mentioned here, you have to make sure that it is the global maximum in the data set. So that is EM algorithm. Now we'll move on to the MCQs. Question 1. Which suggests the existence of efficient recursive algorithm for online smoothing? So basically, this question is asking which is a factor which shows that the algorithm is efficient for online smoothing. Smoothing is basically removing extremities. Extremities is if we have a data range, if there are values way away or far apart from these data ranges, the removing of them is called smoothing. Now, what this requires is for the data set to be same. We have the options matrix, constant space, and constant time. Constant time and matrix cannot be used because the data may change over time, so the answer is constant space B. Second, additional variables are added in HMM in which of the following model? HMM is hidden Markov model. So which of the following can have additional variables added into it? Now, reality and probability model. Reality model is when there are real-time applications required or real-time factors included in this model. So we cannot directly add variables into it. and probability model is not applicable in the case of HMM. So temporal model is used. Temporal model is when there is a model on a given state or given time. So the answer is A. Third, what is the use of hidden Markov model? Like I mentioned, it is similar to the hidden layer networks of neural networks. So speech recognition is definitely one of them. Understanding of the real world cannot be one of the answers because there are real-time factors that are included in option B. So answer A is the answer. Which of the following variables can provide the actual form to the representation of transition model? Here the answer is single and discrete state variable. Single variable is when the variable has one value, and discrete state variable is when that variable has a value that can be counted in a finite amount of time. So both of them are the right answers. The answer is D. Question 5. Which of the following artificial intelligence algorithms works by first running the standard forward pass to compute? Now, artificial intelligence algorithms has two things, forward pass and back pass. Now let's look at the question. Smoothing, modified smoothing, HMM, and depth first search algorithm. So options C and D both use forward and backward pass. So C and D cannot be the answers. Now in smoothing and modified smoothing, I mentioned smoothing are the removing of extremities. Now the question mentions artificial intelligence algorithm. So in modified smoothing, what happens is the removal of extremities is done based on the weights of the inputs. Whereas in smoothing, the extremities are removed. So this is more applicable to the artificial intelligence algorithm. That's why the answer is B. Which of the following, question 6, which of the following tells an increase in online smoothing? The options are matrix formulation, revelation, HMM, and none of the above. So the answer is A. According to the matrix formulation, there is lag, and that is why we can tell if there is an increase in online smoothing. Question 7. What are the likely values of the variables? So variables, literals, and discrete variables are all good answers for this question, but the more appropriate answer is possible states of the world, because a variable can have random values. So the answer here is D. Question 8. Which of the following algorithm is applicable for solving temporal probabilistic reasoning? Now here if you look at the options, option A, C and D are all similar. They are based on solving problems like traveling salesman. At least hill climbing search algorithm is used for solving the traveling salesman problem. They are options A, C and D are all based on making or dividing their data into branches. So here we can use this approach to find the answer is B, or we can also tell that temporal probabilistic reasoning, which is basically on time finding models or finding data set at a specific moment, we use HMM or option B. Question 9. Which of the following permits for a simple and matrix implementation of all the basic algorithms? So we have HMM, restricted structure of HMM, temporary model and reality model. We know C and D cannot be the options. Now in A and B, if we have the question mentions simple and matrix implementation of all the basic algorithms. The more less or the more restricted structure we have of HMM, the more easier it will be to find the global optima or the global minimum, right? So that is why the answer here is restricted structure of HMM, option B. Question 10. How can we describe the state of the process in HMM? So the answer here, according to the last question we did, is single discrete random variable. So the option is C. Answer is C. Okay, going to the numericals. This is a numerical based on the Bayes theorem. We have three factories which produce light bulbs. Factory A produces 20%, factory B produces 50%, and factory C produces 30%, as we've mentioned here as PA, PB, and PC. Now, 2% of the bulbs produced in factory A, 1% of the bulbs produced in factory B, and 3% of the bulbs produced in factory C are defective. We've represented the defective bulbs as PD and we've represented these values as PDA, PDB, and PDC respectively. Now, a bulb is selected at random in the market and is found to be defective. What is the probability that the bulb was produced by factory B? So we want to find PBD. Remember, when we mentioned those assumptions, we did PDB because it was defective and it was in factory B. Now we want to calculate the conditional probability that it was produced in factory B and is defective. So according to the Bayes theorem, we put in these values and we get the answer 0.277. Now, this is the reason behind this is even though factory B produces 50% of the bulbs, the percentage of it being defective is only 1%. That is why 0.277 is the probability that it comes from factory B. Question 2. You are planning a picnic, but the morning is cloudy. 50% of all rainy days start off cloudy. But cloudy mornings are common. About 40% of days start cloudy. And this is a dry month, so only 3 of 30 days tend to be rainy. So basically 10%. Now what is the chance of it raining today? Now let's say we have the chance of, we use rain to mean rain during the day and cloud to mean cloudy in the morning. The chance of rain given cloud is written is P rain comma cloud. Now let's put that in the formula. We know that the probability of rain is 10%. Probability of cloud given that rain happens is 50%. And probability of cloud is 40%. Now P rain dash cloud is equal to 0.1 into 0.5 into 0.4, which is equal to 0.125. So basically 12.5%. So that is not bad. The last is based on the Gaussian model. Let's say we want to add a sprinkler to our garden, but we need to figure out the factors that are needed while making it. So there are 3 variables on which this depends: whether the sprinkler is automatically on or off, whether it is raining, and whether the grass is wet. So you can see here that rain affects both the sprinkler and the wet grass, whereas sprinkler affects only the wet grass. According to the variables, we have made this as the Gaussian model. So these are the references I have used, and I'd like to thank you. The next topic is by Komal.
Hello everyone, my name is Komal Singh and I'm from TENTC, studying in Bharati Vidyapith College of Engineering from Tonnes. And today I'm going to represent my topic, linear model, regression analysis and least square method. So here it goes. First of all, linear model, regression analysis, least square. These 3 topics are interconnected with each other. So first, linear model, which is also known as linear regression model. Regression analysis, in this we have to study number of independent variable, shape of regression analysis, type of dependent variable. These all of things we need to find out in the regression analysis. Then least square. Least square method is a method which we use to find out the linear regression modeling. And then my first topic is linear models. And in linear model which we are also called as linear regression model, there we have 2 parameters, and the first parameter is the slope, then which is also known as a growth factor, and second parameter is a y-intercept, which we are representing here as a b. You can see this in this formula, then which is the initial value. Basically, I can tell you about this in this figure. Like you can see this blue line, this is a slope line. Like here I told you that it is a growth factor. So we can find out growth factor by using the slope formula, and then here this line which is used to find out the position of the any object. Like this is assume like this is the slope line for the car moving. So now we have to find out what is the position of car in this diagram. So here we have to just find out slope value, then which is 200 divided by 10, initial value minus final value, than the initial value of dependent variable. So here the intervals of 10, 10. So 200 divided by 10, we got slope equal to x, slope equal to 20. Then what is our initial intercept? That is 200. So for finding the position of car, like I have taken the example of car, you can take off another also. So for finding out the position of car in any places of these slope, we can use this formula. So it can be very easy to find out. Then my next topic is regression analysis, which is regression analysis is a set of statistical process for estimating the relationship between a dependent variable and one or more independent variables. So basically what we can say that in this we have to find out the one here we have to find the relation between dependent variable and independent variable. So the terminology you will often use to listen if about regression analysis is dependent variable or target variable, which is a variable to predict. Now I'll take one example, like if I'm working in a industry and someone has given me a task like find out the annual sale of the year. So what I have to do first, I have to find out the annual sale, which is my dependent variable. And for affecting these things, we have lots of factors. So those things are called as those factors are called as an independent variable. Like here we can say variable to estimate the dependent variable. So those all factors are depend on one another thing, like which is I have taken here example as annual sale. So and then is another is outlier. Outlier is things like the factor which are not even the close, is not at all close to the data points which we have already predicted. The factor, like we have to find the those value only which come closer to each other, so that we can create a regression line and find out the proper factors, so that there is a less error. And then we can say multicollinearity, situation in which two or more independent variable are highly linearly related. Like in this, if we can say that one factor is affecting the another, like if we change one factor, then another is also getting changed. These things make the model very problematic, and which create lots of errors. So these things should not be come under should remove these things. We use regression analysis, and this thing describe you the number of independent variable, shape of regression line, which means that which data points we have. So those data lines comes closer to that regression line, so that we can cover all of those points. That is called as a shape of regression line. Then next is least square method. Like in first slide also I told you, least square method is the best method to use find the linear regression. And the concept is to draw the line all the plotted data points. Like in this we have different data points, and there we cannot say like which type of line we can represent. So for covering all those points, we make a slope line, and then for the we can make cover all those points. And then the next is the distance is called residual or error. So these distance which are present between this line and the data point is called the residual error, and also called residuals, or we can call as a error. and here this graph represent like this is the line, regression line we call it, and first here our data point is, and what the value we have to predict is the which comes on the regression line, but our observed value is this one, which is called yi, and so we have to find out the least square method so that this error can be reduced. For that we have a formula, summation of yi minus y by I, that, and we had taken square here so that the negative value doesn't come in between that. And next this formula to find out the position of the point, which is very necessary to note it. We will use this these formula in next numericals. So here it goes. First example, the gym has 100 members. The gym plans to increase members by 10 members every year, membership by 10 members every year. Write an equation to represent the relationship between the number of members y and the years from now x. So and then now here you can say a gym has already 100 members. Now to increase the membership by 10 every year, we have to write an equation. Here I have taken for simple example so that everyone can understand what basically we have to do. So we get initial value is 100, that is B-intercept, which we have seen in this slide. Like I'll explain. Here we have seen that initial value is a y-intercept, which is a value of B. Then now we go back to that slide. Yeah, then the rate of change is 10. So this is a slope, which is also told that rate of change or slope is a similar thing. We can consider that as a what was our equation is y equal to mx plus b. So value of b is 100 and the value of m is 10. So this is the equation we will get. Now second question is, suppose your bank account balance y in dollars after t years is given by y equal to 10,000 t plus 50,000. In how many years will you have 1 lakh dollars? So here we have to find like we have to find the number of years which will take to get the 1 lakh dollars. So first we have already given an equation, just we have to put the value of y, like in how many years. So like in the example of car, I had given one equation and I can find out the position at any date, any time. So this is the similar thing, like you have to find the year by putting the value of y which is given. Now I have to find the how many year it will take. So t will describe that the year. This here t is a dependent variable. So we have sorry, we have find out the t equal to 5. Then this is a little bit lengthy but not the difficult one. Tom, who is the owner of a retail shop, found the price of different t-shirt versus the number of t-shirt sold at his shop over a period of 1 week. Now this is the data set we have got. Now we have to find out the slope at his own. Now first step is the slope to find out. Then the formula for slope is this one. Now we can also do one thing, like for all of these parameters we can create a different columns and find all the summation value and directly put in this equation, or we can or else you can do differently calculation. Then we will find m equal to 1.5, which is a slope. Then we have to find the step 2 is to compute the y-intercept value, that is c equal to, here I have written c, previously I had used a b, so don't misinterpret it. Then c is a y-intercept value, and c equal to y minus mx, like y equal to mx plus c, so we have reinterpreted that equation only. So c equal to y minus mx, m value we know that, and summation of x, and take any value of x and y and find out the intercept value. Then step 3 is substitute the value in the final equation. Consider, now I have taken a randomly any number x equal to 8. Like we can take any other number also. So we have to substitute these value in the final equation and find out the value of y. So that y equal to mx plus c. Then y equal to m. Value of m is 1.518 into 8. This is the initial value. Sorry, this is a dependent value, and plus 0.305, which we have find here, and the equation it goes like this, 12.45. So we definitely know that the t should not come like this, so approximately this is 13 t-shirts. Okay, and now the MCQs. If linear regression model perfectly first, that is train error is 0, then now you can see that if linear regression model is perfectly first, then train error is 0. If train error is 0, that means we can say that the test error is also 0. But this is not at all defined, so we cannot comment on this. So the answer is C. Couldn't comment on test error. Here, the next question. Under method of least square, a linear equation is developed in the form of dash, wherein y is the total cost, a equal to fixed cost, b equal to marginal cost, and x is output. So here we can get to know that a is a fixed value, that means it is an initial intercept. So a, we get a, then b is a marginal, so that we can, here we can use it for rate of growth rate. Then y is output, so this equation we have already discussed, that y equal to a plus bx, which is pretty simple, and the answer is a. Then the next question, the parameter e, which we use for least square method is called as. Now we have already seen this in previous slide of least square method, that e represents the summation of y of I minus y of I bar square. Then that is, let me go back to that slide so that we can understand. Yeah, here you can see that y minus I minus y bar I, here this is a residual error, residual sum of residuals. So what we are doing here, what our question is here, the parameter e, which we use for least square method, is called as what? Sum of residues. Then fit the straight line in the following data. Here you can do the same thing which we have done the last numerical in this. Like first we have find out the value of slope, then we have find out the y-intercept, then the final equation. So we have done here same thing in question number 4th. That is, fit the straight line in the equation. So first we have to find the x, then y, then xy, and then x square, and doing the proper calculation we get the value of m, that is slope, which is equal to nearly 0.94. Then we have to find the initial value, that is b, which we also get by using that formula. So we will get that what was the formula is b equal to y minus mx. So we will get b equal to 6.6. So our answer is A. Then question number 5th. In practice, line of best fit or regression line is found when sum of residuals summation y minus h of x is minimum, sum of the absolute value of residual summation of mod y minus h of x is maximum, sum of the square of residual summation y minus h of x square is minimum, sum of the square of residual summation y minus h of x square is maximum. So here what is the best fit? And here we penalize the highest square first, then the smallest square, smallest error. Sorry, here what we do, like first we penalize the highest error, then we smallest error. So here is the difference between the higher error, then the square of higher error, then the smallest error, which should be a minimum, then we will get the best fit line. So answer is C. In a simple linear regression model, one independent variable, if we change the input variable by 1 unit, how much output variable will change? So if a simple linear regression model, so what we have to do, we have a formula y equal to mx plus b. So the simple thing what we have to do, x plus 1, we will have to do that. So what we will get, y equal to mx plus m plus the y-intercept. So what will we see in the output change? We will see the y equal to mx plus m. That means by its slope y will change. So the answer is D. Then question number 7. Dash is an incredible powerful tool for analyzing data. This is very simple. We are already discussing about this, and this is the most easiest and most valuable regression model which we use in data science, machine learning, and that is linear regression model. The eighth one is regression method is also known as the ordinary least square estimation. So here direct regression method is also known as the ordinary least square estimation. Then which of the following metrics can be used for evaluating regression model? Then here R square, adjust R square, F statistic. These all are used for matrices of the regression model for evaluating regression model. And in the regression equation, y equal to b naught plus b1x, b1 is what? So it's a very simple question, like what is b1? I already told you, like y is a predicted value which is independent value, and b naught is a y-intercept, then b1 is a slope. So the slope of the line is called as a b1. So here's all the questions are gone. Like I think you all have understood it. If you have any doubt, you can ask me. All of these are the link. I would prefer you to go all of these links. First one is for least square method and second one is also for least square method, and you will definitely get to know properly about this. And the third one is a course era login, which you can do a course which is definitely tell you all tell you everything about regression model, and the others are the links where you can refer a different uh, criteria of about these parameter, these topics. Then this, thank you, and I hope you have listened it properly and understood. Thank you.
Hello again, Madhura this side. Hope you understood what was taught in each topic and you enjoyed the video. So here are the learnings and challenges faced by our speakers. You may go through them as the motivation for you to present such topics ahead in your future for all the data science learners out there. Thank you so much. You can always reach out to us if you have any queries. Thank you.